What is up, YouTube? Let's learn about authentication and authorization and APIs and their respective protocols. So let's get into it. So what are authentication and authorization? To fulfill our security goals, the API needs to be able to differentiate users in our system and potentially fend off nefarious users. For example, for a banking API, it would be detrimental if we couldn't verify the identity of the individual users using our API. An imposter could gain access to another user's account and the assets within it. Also, not all service users are alike. Some might be individual users, while others might be part of a large organization. The authorization mechanism manages what each user is permitted to do based on their user category, such as having the ability to call different functions or make a specific number of API calls per day. So, authentication and authorization become essential to implementing the security goals we defined earlier. So, authentication refers to the procedure through which our API verifies who the user is. Applications fulfill this by implementing a login system using usernames and passwords for verification. And there are other techniques for authenticating users in the API paradigm that we'll explore later. And authorization is controlling what the user has access to. For example, we may be authorized to view a Google Doc, but not to edit it. So to recap, authentication is verifying the identity of the user, and authorization describes the privileges available to that user. Let's begin by defining some common authentication protocols prevalent in the API landscape. We'll expand on the frameworks that combine and utilize these protocols to implement both authentication and authorization. There are several mechanisms we can explore in this section. We'll begin with one that's largely regarded as the simplest, which is HTTP basic authentication. HTTP basic authentication is a rudimentary scheme that verifies a client through username and password. It encodes the user's username and password in base64 and embeds it into its authorization header. A client with the username Bob and password the farmer will be embedded in the header as follows. So you have this basic keyword and this base64 string. And note that the authorization request header represents the username and password as Bob the farmer, encoded in base64 format, and the basic keyword before the encoded text signifies that this request header is for basic authentication. Once entered, this username and password are sent to the server, which verifies the user. This process is illustrated. So firstly, the client forwards a request to the server. Secondly, the server can't authenticate the client, so it rejects the request and forwards the error message to the client through the www authenticate response header. Through this header, the client is prompted to enter their username and password. Then the client then relays the same request, this time with the encoded username and password along with the request in the authorization header. And fourth, the server verifies the user and allows the request to go through. So what is the purpose of the realm keyword in our authenticate header? So in our first server response, we have this realm keyword in our authenticate header, and the realm keyword signifies the scope of protection, which simply means that it defines an area for which the user's login credentials are used. If a user's credentials are registered on a particular realm, they should be valid for any web page on that same realm. So why do we encode the username and password in base64? As a standard, the usernames and passwords in our HTTP headers should only contain ASCII characters. However, it's possible that a client's credentials include non-ASCII characters, which we can't embed directly into the header. To solve this issue, we encode the credentials in base64, which generates a string containing ASCII characters that can be decoded when received by the server to obtain the actual username and password. And an example of this is the character, whatever this character is, which may be used in a username or password. Because it isn't an ASCII character, we can't embed it into our header. However, its base64 encoded format is this and can be embedded into the header. This method has largely been discontinued in the API landscape because of the drawbacks mentioned below. So we turn to other authentication protocols. So the disadvantages are the client's password will have to be forwarded on every API call, which increases its chance of being intercepted by an attacker, and it's a larger overhead due to authenticating the client for every request, and credentials are encoded instead of being encrypted. But the advantage is that it's very simple. like the most simple out of all the authentication methods. So now let's talk about API keys. API keys deal with the shortcomings of HTTP basic authentication by replacing the encoded username and password with a generated string. API keys are uniquely generated by the API provider for every consumer or application developer to be used in their applications. API keys are merely strings that identify the application, and they require other security protocols for their secure transmission. Note that API keys can't authenticate end users making requests, just the application sending the request, and it's used in tandem with other protocols to implement authentication. So there are various ways in which an application might generate API keys. Some may generate random strings, further encode them, and finally pad with random characters in between. Other APIs increase the number of bits that represent each API key, which reduces both its predictability and increase the number of keys that can be given to applications. And the goal is to provide unique and unguessable keys. And so the following is an example of what an API key might look like, which is this, which just looks like a random string, right? So with API key authentication, the application forwards its assigned API key in the header of its request. When the server receives the said request, it looks up the API key in its database in hopes of verifying the application, and an example of API key generation is shown. So firstly, a client will request to generate an API key, and then the server will create an API key and forward the generated API key back to the client. And then our client will make a request with the API key, and our server will verify the application and it allows the request to go through. So utilizing API keys over HTTP basic authentication has many benefits. So firstly, unlike HTTP basic authentication, API keys provide applications the option to have multiple keys per account. Second, API keys are deemed more convenient than their counterpart, which can be seen in their ability to refresh and regenerate tokens used as API keys. And third, because the API is separate from the user's username and password, any security breach will be limited to the API. Even if the attacker has a compromised key, they won't have the user's credentials. And then fourth, API keys can be revoked if needed, for instance, if the keys are compromised. But it's essential to keep API keys a secret because if an attacker gains access to an API key, the server won't be able to differentiate it from the legitimate user. So the advantages of API keys are it's preferred for their simplicity. Multiple keys can be made from the same master account. It has better security in comparison with HTTP basic authentication. But the disadvantages are it needs another authorization protocol alongside them, or else attackers can gain access to API keys and subsequent permissions. And they have to be sent with every request that requires user authentication. So now let's talk about JWTs. So a JSON Web Token, or JWT, is an open standard that's a compact and self-sufficient method for safely transferring data between entities in the form of JSON objects. So JWTs are a collection of encrypted strings denoting a header, a payload, and a signature that travel through HTTP requests. Unlike the previous protocols, tokens can be used for both authentication and authorization purposes because they carry information about the token's holder. So JWTs are commonplace in the API landscape. An example of a decoded JWT's header is shown below, as you can see, and the header contains information about the hashing algorithm and the token type. In this case above, HS256 is the hashing algorithm and the token type is JWT. Payloads contain statements about the user the token is assigned to, such as its name, issuer, and expiration, amongst other things. And finally, JWTs additionally include a signature that verifies that the holder of the token is legitimate and that the message hasn't been altered in transmission. To generate the signature, we sign the encoded header, the payload, and a secret exclusive to the entity generating the JWT with a hashing algorithm mentioned in the header. And the recipient of the JWT will recalculate and compare the two signatures to determine if it was altered during transmission. An example of signature representation is given below. So we have a base64 URL encode, the header, and we also encode the payload, and we also have a secret. And note that the code above is encoded as strings using base64. The header and payload are separated by a period, and the encoded representation of a token follows the format header dot payload dot signature template. Tokens are embedded with a time limit, after which they are rendered invalid, and a new token has to be generated by using refresh tokens or authenticating into the server again. So here's another example of the structure of our encoded JWTs. We have the header, payload, and signature. So the pictures illustrate the creation and usage of tokens. So first, the client sends an authenticate request to the server with their username and password using HTTP authentication, and the application validates the request and then creates a token for the client. So first we have our post request from our client with our username and password, and then our server then generates a token for our client and sends this token back. And then our token is stored on the client side and is sent through the HTTP authorization header to the server when requests are being made. The bearer keyword signifies that this authentication scheme is token-based, similar to how the basic keyword earlier signified how basic authentication was being used. This request can be interpreted as requesting access to the bearer of this token. So our client, saves the JWT and then sends it in our GET request to the server. And then on arrival of the request, the server verifies the token. On successful verification, the server sends back an appropriate response to the client. And in the pictures, a GET request is put for the client's username, which is returned after verification of the token and the request. So our server verifies the request and sends back whatever the client is requesting. API keys and tokens may seem similar, but there are a few key differences. API keys only serve to identify the client, whereas tokens carry more information with them, such as their source, the identifier, and other metadata. This extra information is helpful for authorization purposes. Tokens are structured to contain a header and a payload. API keys are just generated strings. So let's talk about the pros and cons of each technique. So basic authentication is the simplest of all the authentication methods, but the disadvantages are the client's password will have to be forwarded on every API call, and it increases the chances of being intercepted. It adds overhead needing to authenticate the client for every request, and credentials are encoded instead of being encrypted. API keys are preferred for its simplicity. They have multiple API keys that can be made for the same master account. It has better security in comparison to basic authentication, but it needs another authorization protocol alongside them, or else attackers can gain access to API keys and the subsequent permissions, and they have to be sent with every request that requires user authentication. But JWTs they're scalable, and they offer temporary access to specific resources, and they're widely used in the API landscape. But the disadvantages are processing JWTs can cause overhead, and they require understanding of cryptographic signatures. Before we wrap up, let's look at the use cases in which API keys and JWTs may be helpful. In the case of blocking unauthorized traffic to our API, keys should be used because they authenticate the applications making the request. API keys are also used in implementing rate limiting, which controls how many calls to a specific application is allowed to an API. They can also be used to filter logs by the specific API key. In projects where we need to identify the end user, JWTs are preferred because keys only identify the application, not the user making the request. And in this video, we've explored various authentication and authorization protocols and their respective advantages and disadvantages. In the following video, we'll examine how these protocols are incorporated in different frameworks popular in the API landscape to fulfill our API security goals. So let's do a quick quiz. Suppose we want to build a web application that allows users to book flights. We want to ensure that only the users who have purchased a ticket can view their flight details. What security mechanism would you use to verify the user's eligibility to view their flight details? Is it authentication or authorization? So the answer to this is authorization, since this allows the users who bought a ticket to view the flight details for a specific flight. So as you know, authorization is what the user has access to, so this is a good example of that. Thanks so much for watching. This is a concept that a lot of programmers work with, and I really hope you learned something. If you liked the video, leave a thumbs up and subscribe. And if you have any questions, leave a comment, and I'll see you in the next one.